Hello and welcome to this video on subtracting rational expressions with a common denominator. So it's just, subtraction of fractions where the two fractions have the same denominator already, which is what you want to have when you're adding or subtracting fractions. So just a few examples of that. Let's begin. My first example is this here. Find the difference, right? Subtract. The difference, when you see the word difference, it means you're subtracting of these two rational expressions, right? Polynomial over polynomial. You have 8y over 2y minus 5 minus, and then this fraction 6 over 2y minus 5. Again, notice that they have the same denominator, which is necessary for addition and subtraction. Right, same denominator. So this is a little bit of a recap. Maybe you go back to subtracting some numbers here. Put up a little example off to the side of what you do when you subtract, rational numbers. So for example, say I were to take 3 over 10, 3/10, and subtract from that 7/10. Okay. So the denominators are the same. Again, necessary when you are adding or subtracting. When you add or subtract and the two fractions have the same denominator, that common denominator is going to stick around. That will be the denominator of the resulting difference or the resulting sum. So 10 here, 10 here, 10 here. It's the numerators that get combined. So the numerator of the difference will be the difference of these numerators in this order. So the first numerator minus the second numerator, 3 minus 7. So what I'd end up with here is, 3 minus 7 is negative 4 over 10, or you might say this is negative 4/10. And this is all well and good. This is the difference between 3/10 and 7/10, right? Negative 4/10. But it's not completely simplified, right? So we're also going to be simplifying our fractions, right? Making sure that the numerator and denominator have no common factor. Alright, so here, 4 is 2 times 2, so this is, I'll just slide the minus sign to the middle here in line with the fraction bar. And the numerator, you got 2 times 2, and the denominator 10 is 2 times 5, and then you see in some common factors canceling, you can divide out the 2's, right? Remember, again, technically these become 1, right? So it's like 1 times 2, 1 times 5 in the numerator and denominator. So this is negative 2/5. Negative 2/5 would be the final result of my subtraction of 3/10 and 7/10. Alright, so in general, what's going to be happening here is if I have a fraction, say a over c, and I subtract from that another fraction, b over c, or again, I'm just doing some simple examples today where the denominators are already the same, c and c, then their difference, right, the resulting fraction will have that same common denominator of c, and the numerator of the difference is the difference of the numerators. So the numerator is a, first numerator a, minus the second numerator b. Okay. And one thing to point out here too is that when we're subtracting fractions, whenever we have fractions, when denominators, the denominator cannot be equal to 0 at any point, for any value of the variables I plug in, because dividing by 0 is an undefined operation. It doesn't make any sense. So just keep that in mind, that c cannot be 0. The denominators cannot be 0 at any point. Alright, so back to my, let's separate this. So back to my example that's given, finding the difference between these two fractions. I'm going to put them together. This is equal to, and then they already have the same denominator, right? And I'm adding or subtracting here. So the result is going to have that denominator. Right? So the denominator of the difference will be 2y minus 5. Okay. And the numerator is going to be the first numerator minus the second numerator. And each of these numerators is a single term, one term, so I don't need to put parentheses around them. We'll see later, when there are multiple terms, more than one term in your numerators, I'm going to put parentheses around them to make it easier for me. Right. So first numerator, just the single term 8y minus, and the second numerator is just the single term 6. Alright, and this is great. This fraction is the difference between these two fractions. It's just, is it completely simplified? Okay, so I mean, if you were to factor the numerator, right, so here comes some factoring. The numerator has a greatest common factor of these two terms of 2. If I were to pull 2 out, then you'd have 4y minus 3 left over, and the denominator, the greatest common factor of these two terms is simply 1, so that's it. It's just 2y minus 5. If you want to put it in parentheses, that's fine too. Same thing. So I'm not seeing, there's a factor of 2 up here. There's no factor of 2 down here. Yeah, there's a number 2, but it's not a factor. It's not part of the product. And I'm seeing 4y minus 3 up here. There's no 4y minus 3 down here. So this is actually it right here. All right, this fraction here is completely simplified. And one other thing to point out, right, as I mentioned over here, denominators can never be 0. So I'll put a little semicolon or a comma, and off to the side, I'll put the values of the variable that I cannot plug in. All right, so this fraction minus this fraction will be equal to this fraction, just so long as denominators are never 0. Okay, so look at the denominator here. The only denominator throughout this entire problem, the only factor in the denominator, is 2y minus 5. So 2y minus 5 can't be 0. So when is it equal to 0? Well, you would set it equal to 0, then add 5 and divide by 2. Y cannot be positive 5 halves, or 2.5. Right? Because if y were 5 halves, you'd be dividing by 0 here, here, and here. And that's no good. Alright, so that's how I'm going to end this. Alright. So this fraction minus this fraction will be equal to this fraction, as long as the value of y you plug in isn't 5 halves. And let's test that out. I'm going to try to plug in a value and see if indeed this fraction minus this fraction is equal to this fraction. Again, I'm going to plug in a value of y that is not 2.5, not 5 halves. So let's try 1. How about y equals 1? Alright. So I'm going to plug in 1 back in the original fractions. So the first fraction, the numerator would be 8, right? 8 times 1. The denominator would be 2 times 1 minus 5. 2 minus 5, that's negative 3. So this is negative 8/3, or I just slid the negative sign to the middle here. So the first fraction would be negative 8/3. Then we have minus, and then the next fraction, the numerator is 6. And again, the denominator is negative 3, so again I slide the minus there. And here we have a minus minus. So this is really negative 8/3 plus 6/3. And I know 6/3 is 2. Alright, 6 divided by 3 is 2, but I want the same denominator so that I can actually add these together. and the resulting fraction will have that common denominator, and then we just add the numerators, negative 8 plus 6, so negative 2. So I'm getting a result of negative 2/3 when I plug in y equals 1 here and here. All right? So this minus this is negative 2/3. Now check the result out, our final result. 8 times 1 is 8, minus 6 is 2, divided by, and then 2 times 1 minus 5 is 2 minus 5, that's negative 3. And again, I'm just going to slide the negative sign from the denominator to the middle here. And look, it is the same. Great. We get the same value, and that should happen no matter what you plug in for y. So plug in 100, 10, a million, a third, a fifth, negative 5. Plug in whatever you want for y here and here and here, and the difference of these two fractions should be equal to this fraction down here. All right, as long as you don't plug in 5/2, right? Because then you'll be dividing by 0 in the problem somewhere, so no good. All right, so let's try that again. Find the difference. All right, so here I'm trying to find the difference again, subtract these two fractions. Got 10 plus 3z divided by 6z minus, and then 7 divided by 6z. So again, I'm noticing they have the same denominator, so I can put them together right now. Alright, so here's what I mentioned last example. I personally like doing this, and it will help you in the long run, I promise you, if you get in the habit of this. You know, the denominator of the new fraction will be 6z, right? It'll be the same as all the denominators are the same when you go through addition and subtraction. The numerator will be a combination of the previous two numerators, right? So the new numerator in the difference will be the first numerator, and here's where I'm using parentheses, 10 plus 3z, or if you want to write 3z plus 10, that's fine too. But this whole thing in parentheses, that's the first numerator. Then minus, and then the second numerator only has a single term, so I don't really need parentheses around it, and there we go. And then we'll do a little simplification up here in a second. Now, I know what you're thinking, hey, you don't really need parentheses around this. It's not being multiplied, there's nothing to distribute, not being multiplied by anything, and it's not being raised to any powers. And you'd be correct in saying that. But you're going to see that when the second numerator has more than one term, it's going to be beneficial that we get in the habit of putting our numerators in parentheses when combining. Alright, so then combine like terms, let's simplify this. So I've got a term of positive 10, another term of negative 7, that makes a positive 3, and I like to put things in descending order. So instead of putting the positive 3 first, I'm going to put the positive 3z, right, the z term, put it in descending order in terms of z to the first, then no z. So the positive 3z, and then 10 plus negative 7, positive 3. Alright, so there's a numerator where all the like terms are combined, and the denominator is 6z still. And, I'll try factoring stuff now. See if we can simplify this. The numerator, right, these two terms have a greatest common factor of 3. So I pull that out, and what's left over would be z plus 1. The denominator has a factor of 6 and z, but 6 can be broken down further. 6 is 2 times 3 times, and then you have the z. So I am seeing a common factor in the numerator and denominator that we can, divide out and simplify this fraction. So I see a common factor of 3, right? And remember, these technically become 1, right? 3 divided by 3 would be 1. But I've eliminated those factors of 3, and now I'm left with the following. Right? So the only factor left in the numerator is z plus 1. And since it's the only factor left, I don't need to put parentheses around it, but you can if you want. It wouldn't be wrong. then divided by, and then the only factors left in the denominator are 2 times z, or 2z. Great. So there's your simplified difference between these two fractions. This fraction minus this fraction is equal to this fraction. But again, that's not always going to happen. There are some values of z that are not allowed. Right? So basically, you go back through the problem and say, what value of z or values of z would make me divide by 0 at some point during this problem? Well, if you look at the end here in the factored form, z, if z were 0, you'd have 0 in the denominator, right? Same thing here, same thing here. Right? It's the same denominator throughout this entire problem. So z cannot be the number 0, right? But I can replace z with anything else I want, and this minus this will be this. And just so long as my value of z is not 0. All right, and let's test it out. Let's try something. So I'm going to try, how about just z equals, well, again, not 0. Let me go with 2 this time. All right, and again, it can be anything you want, just not 0. And let's see, when I replace z with 2 in this problem, is this fraction minus this fraction equal to this fraction? Alright, so back up here in the original, when I replace z with 2, that'd be 10 plus 3 times 2. Well, 3 times 2 is 6. 10 plus 6 would be 16 in the numerator there. And then the denominator would be 6 times 2, or 12. Okay, then minus. Then the second fraction, you have 7 in the numerator, divided by, and then again 6 times 2, you have 12 in the denominator. And they have the same denominator, so I'm just going to leave them that way, and the resulting difference will have a denominator of 12. And the numerator will be 16 minus 7, which is 9. Right? 16 minus 7, which is 9. And then if we completely simplify, right, this is 3 times 3, this is 3 times 4. They have a common factor of 3. When I divide out the common factor of 3, I'm left with 3/4. Right? So when z is 2, this fraction minus this fraction is 3/4. Well, let's see, is this fraction also 3/4? Well, let's see, when I replace z with 2, that'd be 2 plus 1, 3 for the numerator, and then 2 times 2, 4 for the denominator. Yes, indeed, it is the same value. And that should be the case. If you did this correctly, that should be the case, where this fraction is equal to the difference of these two, no matter what you plug in for z, except 0. Right? So try some other numbers, right? 3, 5, a million, -10, whatever you want, as long as it's not 0. Alright, so I just got a couple more here. Some involving some quadratic polynomials, right? I haven't seen any degree 2 polynomials yet, so here's another one where I have fraction minus fraction, and again, a nice simple example where the fractions have the same denominator. Alright, so since they have the same denominator, I am going to put them together now. I'll just say we can subtract the fractions now. The denominator of the difference will be that common denominator, 3x, 3x, 3x. And we're going to get our new numerator will be a combination of these two. So again, now each of these numerators has 2 terms, right? 2x squared negative 5x, and this numerator has 2 terms, x squared and negative 13x. Alright, so the first numerator, again, if it has multiple terms, I'm going to put it in parentheses. This is 2x squared minus 5x. And then we are subtracting, so minus. And then the second numerator is, again, multiple terms, so I'm going to put it in parentheses, x squared minus 13x. Right, and now you see, hopefully you can see now why the parentheses will be necessary in some cases. Because in this first grouping here, the first set of parentheses, I don't really need these, because there's nothing in front to distribute, and it's not being raised to any powers. But this second group of parentheses is necessary, because the number in front, remember a minus sign, when you see a minus sign, technically that represents the number -1. Just like, minus 5x is just like -1 times 5x. Minus 13x is -1 times 13x. So this is like having a -1 here. And I'm going to be distributing that -1 over both of those terms from the second numerator. So be careful. Don't just subtract the first term, right? You are subtracting this entire numerator, distributing. Alright, so I will write that out. Alright, so this is equal to, alright, again, the denominator is 3x. Okay. Didn't need the parentheses around the first group, right? So that's 2x squared minus 5x. And then after distributing the -1 over the second numerator, the second group, get minus x squared and then plus 13x. Alright, and then I'll combine some like terms up here and we'll get our new numerator. Alright, and again, I like to go in descending order, so highest power of x first. So we have 2x squared here, -1x squared here, that makes positive 1x squared. And then you have the x to the first terms, -5x, and then positive 13x. When you combine those, it would be positive 8x. 13 minus 5. And then all of that divided by 3x. Alright, great. So this is the difference of these two fractions. It's just I would like to now completely simplify it. So now we're going to go to our factoring. I'm going to factor the numerator, factor the denominator completely. In the numerator, there is a greatest common factor of these two terms is x. I can factor out an x. And then what's left over would be x plus 8. And then in the denominator, 3 is prime, and you just have the factors of 3 and x, 3 times x. Okay, so I am seeing a common factor here, but before, like in other videos I've put out where we simplify fractions, or you can look up other videos if you want, or read your book. Before I simplify, before canceling any common factors that the numerator and denominator have, I'm going to point out some values that are unusable. So in this particular example, the value of x cannot be replaced with 0, right? Throughout this entire problem so far, the denominator has been 3 times x, 3 times x. So this factor of x in the denominator, right, that cannot be 0. Because if it were 0, we'd have 3 times 0, we'd have 0 in the denominator. Alright, so as long as x is not 0, we can continue on with simplification. We can cancel these common factors of x, right? There's x here, and those technically again become 1. If you want to write 1, that's fine. So now when all's said and done, when it's completely simplified, this fraction minus this fraction equals, well, the only factor left in the numerator is x plus 8, and since it is the only factor left, I don't really need parentheses around it, but you can put them if you want. Divided by, and then after the canceling, the only factor left in the denominator is 3. Again, the only way this is going to happen though, right, the only way this fraction minus this fraction will be equal to this simplified fraction is if the value of x is not 0, right, because again I would be dividing by 0 here and here, and that's no good. So I'll close this off and let's check it out. Let's test it. Alright, so let's try a value of x that's not 0. How about x equals, let's try -1. Why not? Alright, plug in anything you want, but not 0. And see if this fraction minus this fraction is indeed equal to this fraction. And it should be if we did everything right. Now let's do the first fraction up here. Let's try the original. When x is -1, right, -1 squared would be +1, right? -1 times -1. So that's 2 times 1, 2. And then negative 5 times negative 1 would be plus 5. So this would be 2 plus 5, or 7, in the numerator of that fraction. And then the denominator would be 3 times negative 1, which would be negative 3. And again, you can put the negative down here. I like to put it, slide it up to the middle in line with the fraction bar. So I've got negative 7/3 for the first fraction, minus, and then the second fraction, the numerator, when I plug in negative 1, right, negative 1 squared is again positive 1, so that's 1. Then negative 13 times negative 1 would be positive 13, so 1 plus 13. So I'd have 14 in the numerator of that fraction. And then again we'd have negative 3, so 3 here, slide the negative out. And you see here we have again a minus, minus a negative, so that'll be plus. All right, so this will be negative 7/3, plus 14/3. And we're adding two fractions that have the same denominator. We keep the denominator, right? That common denominator stays throughout. The only things that get combined are the numerators. Negative 7 plus 14 would be 7. So I end up with 7/3, all right, when I plug in negative 1 for x, when I subtract these two fractions. Now let's see what happens in this one. All right, is it indeed equal to the final result that we got here, the x plus 8 divided by 3? Well, the numerator, when x is negative 1, would be negative 1 plus 8, that'd be 7. And the denominator is 3. It's always 3. And oh look, that is exactly the same as what we got by subtracting these two. So yes, indeed, subtracting these two fractions gives me the same result as this fraction here, when x is negative 1. And that will work. That should work when x is any number. Try any other number except 0, right? Because I'll be dividing by 0. Right? So try that out with 2, 5, a million, 1/3, some fractions, pi, square root of 2, whatever you want except 0. All right, and I have one last example with a bunch of quadratics in it. But again, we're doing the same thing. I'm asked to find the difference between these two fractions, right? Subtract these fractions. And the fractions have the same denominator already. So because the fractions have the same denominator, I can put them together. Right? When adding and subtracting, you need the same denominator, and that same denominator, that common denominator, will be the denominator of the difference. So x squared minus 3x minus 28 in the denominator. And then my numerators, right? So the first numerator is the quantity. Again, I'm putting it, because it has multiple terms, I'm putting it in parentheses. So in the numerator, right, I'm subtracting these two numerators. So the first numerator is 3x squared plus 8x minus 1. And then we're subtracting, right, subtracting the whole second numerator, right? You're not just subtracting the first term here. You're not just subtracting 2x squared. You are subtracting this entire numerator minus the quantity, right, in parentheses, 2x squared plus 2x minus 9, right? And all of that is in the new numerator. All right, so the parentheses aren't really necessary, again, around the first group because there's nothing to distribute and it's not being raised to any powers. But it is necessary around the second group because, again, this minus sign is technically representing the number negative 1. So what I'm doing here is distributing. I'm multiplying the entire second group by negative 1. All right, so when I do this, I have 3x squared plus 8x minus 1, right, that first numerator, and then minus the second numerator, so minus 2x squared. And then minus 2x, and then minus negative 9, that'd be plus 9. All right, so that whole thing is the new numerator, and that common denominator is still x squared minus 3x minus 28. And then I'll simplify the numerator a bit. We'll combine some like terms. Again, I like to go in descending order. So the x squared terms first, 3x squared minus 2x squared be 1x squared. And then your x's, you have 8x minus 2x, so positive 6x. And then your constants, negative 1 plus 9 be plus 8. Right. Okay, and then that's the new numerator, x squared plus 6x plus 8 divided by x squared minus 3x minus 28, right? That common denominator that the two fractions had. And wonderful, this fraction minus this fraction will be equal to this fraction, but I would like to, continue to try and simplify the fraction. Do the numerator and denominator have any common factors? And I want to point out here, as I have in other videos, right, you can only cancel common factors, parts of products. You cannot cancel common terms. Like, don't cross off the x squareds. Like, I know, oh, there's an x squared here in the numerator and in the denominator. I'll cancel those. And the x's, cancel those. Don't do that. These are terms. This is x squared plus 6x plus 8. This is part of a sum. Same thing down here. This is part of a sum. You cannot cancel common terms. You can only cancel common factors. And factors are parts of a product. Right? If this was x squared times 6x times 8, and x squared times 3x times 28, then I could cancel the x squareds and the x's, because it would be all part of a product. Alright, so be careful with that. Alright, so now here comes my factoring part, right? Actually writing these as a product so I can cancel stuff. Now again, you can look at videos I've put up before, that other people have put up that are probably better than mine, about factoring quadratics. I'm just going to jump to it. X squared plus 6x plus 8 would factor to x plus 4 times x plus 2. And again, you can double check, multiply these, FOIL, you would get that back. And the denominator, x squared minus 3x minus 28, that would factor to x minus 7 times x plus 4, or x plus 4 times x minus 7. Again, you can double check by multiplying these and combining like terms. Alright, now, great, we have factored it, and we see the common factor. Hopefully you see the common factor of x plus 4. But even remember, before I cancel, I'm going to write down the numbers that x cannot be. Right? What makes me divide by 0? What gives me 0 in a denominator anywhere throughout the problem? So when I've completely factored everything, I'm seeing in the denominator a factor of x minus 7. So x cannot be 7, right? Because that would make this 0, and then 0 times anything is 0, right? So you'd have 0 in the denominator. And you could even go back to here, right? This x squared minus 3x minus 28 is the same thing. Plug in 7 here and here, and you'll see you get 0. 49 minus 21 minus 28, that is indeed 0. So x cannot be 7, but also, right, this time there's another factor with a variable in the denominator, this x plus 4. So not only can x not be 7, it cannot be negative 4 either. Right? Because if you plug in negative 4 for x, that'll be, negative 4 plus 4 is 0. And then 0 times anything is 0. You'd have 0 in the denominator in this problem. And that's no good. And again, you could check it back here in the original, the way it originally looked. 16 plus 12 minus 28 is 0. Right? When you plug in negative 4 for x. So x cannot be 7, and it cannot be negative 4. But as long as you plug in a value that's not one of these two, you can cancel, you can simplify. You won't have 0 in the denominator. So as long as x is not one of these numbers, we can say, hey, this is not 0, and this is the same non-zero number down here. Any non-zero number divided by the same non-zero number will be 1, right? Technically, again, these become 1. And that's it. That's the only common factor I'm seeing in the numerator and denominator. And then we can finally say that this fraction minus this fraction is equal to, I have x plus 2 in the numerator divided by, and then x minus 7 in the denominator. Okay, wonderful. Again, the only way this is going to work, though, is if the value of x I choose is not 7 and also not -4, right? If you choose x to be one of these, you'll be dividing by 0 in your original fractions, and that is no good. Alright, and let me check this out. I'm going to try just one last time here. I'm going to test this out with a number. Okay. Let's try about 8. Alright, I'm only doing that because I'm seeing the denominator here will be 1. So let's see, when x equals 8, now the numbers will be a bit big, but it'll be manageable. When x equals 8, let's see if this fraction minus this fraction is equal to this fraction when x is 8, and it should be, right? As long as it's not 7 or -4, they should be equal. Let's see, back up here. We have, I'm going to write this out here, we have 3 times 64, right, 8 squared, plus, and then 8 times 8 is another 64, right? And then minus 1 in that numerator. And then this denominator, we know that that's x minus 7 times x plus 4, right? X squared minus 3x minus 28. So when I plug in 8 here, that's, 1 times 12. So this is going to be 12, and you can check it out. That'd be 64, and then minus, 24 minus 28, right? 64 minus 52, 12. So the denominator is 12 for that. Minus, and then this numerator over here, right, we have 2 times 64, right, 2 times 8 squared plus 2 times 8 is 16, it's plus 16, and then minus 9, and then again all that is over 12. Alright, so what I'm noticing here is this is 3 64s, this is another 64, that's 4 times 64, these two, right, 4 times 64. And we're going to be subtracting 2 64s. So I'm getting 4 64s minus 2 64s. That'll just leave me with 2 64s. And 2 times 64 is 128. Alright, and then you have a -1 and positive 9 and positive 16, right, with the rest of it. So you have 128. And then -1, minus 16 would be -17, and minus -9 would be plus 9. So you have 128 minus 8, basically. So you're left with 120 in the numerator, and divided by, when I combine those numerators, it's going to be 120, and then the common denominator stays, and then 120 divided by 12 is 10. Alright, so that was a lot, sorry, and if you didn't understand this, actually work them out. Do this and this and this, and combine all the numerators. And then lastly, let me check. Well, okay, that was this fraction minus this fraction when I plugged in 8. What's the value of this fraction when I plug in 8? Oh, look, 8 plus 2, the numerator is 10, divided by, and then 8 minus 7, the denominator is 1. 10 divided by 1 is indeed 10. So this minus this is equal to this when x equals 8, and it will be that way when x is any number. Try anything else. Try 0, 1,000,000, 5, 1,000th, 1/3, whatever you want, as long as it's not 7 or -4, and they should be equal. Alright, so that's it today. Several examples where I subtracted fractions with the same denominator and simplified. And as always, I like to say, please try to understand things. Try to work things out so that you understand them on your own first. I find that things stick better when you've worked on it and learned it on your own. So read through the material, read through the examples, try to understand them as best you can. Work on problems on your own. Check answers in the back of the book if there are any. And don't just give up after the first attempt. If after the first attempt you're not getting it, try it several more times. If after several attempts you're still not understanding, it's still not clicking, maybe even try reading through the material again. Maybe something will click the next time, the second time or third time through that didn't click the first time. reading through the material and the author's examples again. But if after that, if after several readings of the material, several attempts at a problem, you're still not getting it, it is not a sign of weakness whatsoever to go out looking for help. Ask for help. Ask your teachers, your tutor, a friend who understands the material, or somebody else in the class. Look for videos on the material, maybe like this one showing you examples, or other ones out there that are, I'm sure, much better than the ones I put up. But they're out there. And stay persistent, keep at it, keep practicing, and I know you'll get it. I know you'll get it. And try your best to have fun with it too. All right, thank you.